Okay, so let's start by talking about what we actually want. Now, at the end of this session, we want to know about the routines that help us to make messy data tidy. So it's very important to understand what is tidy data. So what's our goal? Here's a quote from one of the people that is shaping the R language very heavily, Hadley Wickham. He's, for instance, the developer of ggplot and the two packages we are about to use in this session. He's also the person who has coined the term tidy data. And he says that tidy data sets are all alike, but every messy data set is messy on its own, in its own way. So that's the thing that I mentioned before. The data you find in reality comes in many, many different shapes. The data we want to have should be tidy, and there's only one single definition of a tidy data set, and for every data set there's only one way in which this data set can be tidy. And that's actually pretty cool. What he actually wants to say in plain English here is therefore that we find all kinds of fucked up data sets in the world, and we always need to turn them into something that's a good starting point for any further tasks. And this form is unique, and it's called a tidy data set. So here is how a tidy data set looks like. This is an example I brought for you for a tidy data set. What are the main properties of this data set? First of all, every column in this data set corresponds to one and only one variable. So in this case here, we have 4 columns, meaning that there are 4 variables. The first variable is called C code. A little bit of thinking helps you to understand that this name refers to something like country code, because this column obviously indicates to which country the observation there refers. AT for Austria and DE for Germany. The second variable is year. The third variable in the third column is exports, and the fourth variable in the fourth column is unemployment. There is no column that contains more than one variable. It might be at first sight a little bit counterintuitive to say that something like year or country code is a variable, but this is actually something that you collect from the observations in your data. So I think it's defendable to call it variable. But I hope you get the general point. So that's the first property every tidy data set needs to have. The second demand every tidy data set needs to fulfill is that every row corresponds to one and only one observation. So in this case here, you see that the first row corresponds to an observation in Austria in the year 2013. Now, in this data set, it is obviously true that for each year there's only one observation. So the year is fully sufficient to determine the time of observation. Also, there are observations for 2 kinds of countries, Austria and Germany, and the information you get from each row is sufficient to determine to which country and to which time the observation refers to. So the first row is about an observation of in Austria for the year 2013, second row for Austria in 2014, and the information in this row is completely sufficient to determine what observation we are referring to. Now, the third demand that any tidy data set needs to fulfill is that every cell corresponds to one and only one value. So you see here in the first row and the first column, AT, there is only one thing written in this cell, namely the country code AT. In the second column, again, there is only one thing written down, a year, 2013. Well, this demand sometimes requires you to interpret the data, because here it's very obvious that in every cell there's only one value. But sometimes the values are unique in the sense that you're talking about only one string, but nevertheless the string refers to more values. So, for example, if we had written in the first row and the first column AT and DE, within one string, we would only have one string, but AT and DE would be 2 values, and then we wouldn't have a tidy data set anymore. So you need to think about that a little bit. sometimes, but in most of the cases, it's very clear whether this demand is fulfilled or not. And every data set that fulfills these three demands is called tidy. And this is what we want, because this is the form that programming languages such as R can usually process quite well. Then you might ask yourself, okay, if this data format is so great for analysis, why isn't every data set in this world tidy right from the start? First of all, when you collect data yourself, you might be too lazy to turn the data set into this format. And then again, for big databases in the internet, it might be costly in terms of storage. So there are all kind of pragmatic, non-pragmatic reasons for why the stuff you find in the real world is not tidy right from the start. And sometimes you might even have a tidy data set and you might want to transform it into a non-tidy data set. Why? Because tidy data is very useful for machines, but oftentimes it's not that great if you want to communicate a data set through a table to humans. Because for humans, it's often easier to read non-tidy data sets. So for instance, in the data set here, it might be nice to have the years in the different columns. So you have each column referring to 1 year. So you have one column for 2013 and the other for 2014. That's because as humans, we're trained, at least in Europe, to read from left to right. So if we want to grasp dynamics of a certain variable, we might want to read from left to right, having the years corresponding to the different columns. So in this case, you might want to take a tidy data set and make it untidy if you want to put it into your paper. But the good thing is that for turning an untidy data set into a data set like this, you need to implement the same routines you need to learn when creating a tidy data set from a messy data set at all. So there's no additional effort necessary for you. Main message right now, this here, this data structure, this is what we want to get. This is what we want to turn the data sets we find in the real world turn into. At this point, it might be useful to take a break and think again about what these three demands for tidy data actually mean in practice. So here I brought to you 3 examples for data sets that are not tidy. And I would recommend you to, after seeing the data set, pause the video for a few seconds, think about yourself of why this data set is not tidy and what would be needed to change to make it tidy, and then look at the solution. So here's the first one. Now, if you think about it a little, which of the 3 demands for tidy data could be violated here, you will immediately see that the rows do not correspond to one and only one observation in this case. This is a data set that's quite nicely for the presentation to humans. Remember the examples I gave. Humans, especially in Europe, are good at reading from left to right, so they can grasp dynamics in certain variables better if they present it in this way here. Because in the first row, you see the value for unemployment in Austria, both for the year 2013 and 2014. And you can basically grasp the change from one year to the other by reading the values from left to right. So this is something you see very, very often in papers. And there's nothing bad with this kind of presentation of data. It's just not very useful if you want to analyze or process this data in R. So here you see that, as I said, in the first row, you do not have only one observation, but you actually have 2 observations. 2 observations for Austria, namely 1 observation for 2013 and 1 observation for 2014. You actually also see that the second demand for tidy data, namely that each column must refer to one and only one variable, is also violated because you have 2 columns that both refer to the variable year. This is a little bit more difficult to spot because then you need to think about what are actually the variables in the data set, and you don't see them immediately because they are hidden behind two columns in this case, but it doesn't change the outcome that this is definitely not a tidy data set. It's not a bad data set, it's just not tidy, and what you need to do is basically you need to create a new column called year, into which you put the 2013 and 14, and you need to create another new column called unemployment, where you then put the values that you see in this table. What about this data set here? Here again, it's not tidy, obviously, because every column doesn't correspond to one and only one variable. Why? It's actually a similar problem as with the first one, in the sense that you also have this column called variable. And well, a column called variable is not necessarily a variable. It's a description of what's written in the other columns, in the sense that it might contain some information about what the other columns refer to. So in this case here, we actually have a double information, because in the third column, you see the variable from the title of the column. You can see, okay, this column refers to the variable exports. And then you have a fourth column called variable that basically says that in each row, the values refer to the variable export. So it's actually too much information here. It's redundant, and you could make this data set tidy by just removing the fourth column. Nevertheless, this is something you see quite often, actually, especially when you have data set with several variables. Then sometimes you have this column called variable, and then another column called value. And then from what is written in the column variable, you can refer to which variable the value in the column value actually refers to. Then you need to squeeze or wrangle the data set a little bit. In any case, it's not tidy, because not every column refers to only one variable. And here's the third example. Okay, you see, this is a data set illustrating the example that I mentioned before, where we actually violate the third demand for tidy data, namely that every cell corresponds to one and only one value. You might see this kind of presentation in papers, where you have kind of summary table, where people try to summarize what they've written before in an illustrative way. So think, for example, about a paper in which the person writes about the most important industries in countries and their share of, like, I don't know, total value added or so. And then it might be good to have a table like this, where you see, okay, for the country Germany, like the car manufacturing industry and the meat industry are particularly important, and for Austria, it's the wine industry and the milk industry. So there's nothing wrong with this kind of presentation in some sense, but it's definitely not a tidy data set. Why? Because in the second column, we have several values. We have the share of cars in value added, and the share of meat in value added when it comes to Germany, and the share of wine to value added and milk to value added when it comes to Austria, assuming these percentages refer to the share of value added of these industries for the overall GDP in these countries. I mean, that's not written in there, but it would make sense. In any case, this is not a tidy data set. If you find these kind of data sets, it's gonna be quite difficult to turn them into a tidy data set, because you really need to change the values in the cells, and that's not always straightforward. It's completely feasible and it's possible, but it usually requires a bit more work than the data sets in the other two examples. In any case, all of these data sets are quite common in the real world, but they are not what we want. What we need to learn is how to turn these kind of data sets into tidy data sets, and we can achieve this with the routines we will learn about soon. In this context, you will often hear about the term data wrangling. Data wrangling usually refers to turning untidy data into tidy data. Here, I prefer using the term data preparation because this is broader. When you get a data set from the real world and you want to use it for your analysis, Making it tidy is one absolutely essential step, but sometimes you need to take further steps, like, for example, computing means or averaging, observations over years, etc., etc. And I think it makes sense to look at all these routines and processes under the topic of data preparation, because steps for making untidy data tidy and manipulating data are often intermingled, so you usually address them within one script or one preparatory step in your data analysis. But if you see the term data wrangling, that usually refers to the act of turning data sets like this into tidy data sets.